This object is almost too massive to be called a planet. And that is exactly why it matters. Because 29 Cygni b sits right on one of the strangest borders in astronomy. The line where a giant planet starts looking more like a failed star. It weighs about 15 times as much as Jupiter. At that size, you would be forgiven for thinking this thing should not count as a planet at all. But Webb just gave astronomers one of the clearest answers yet. And the answer is not what you would expect. For a long time, the biggest worlds in space have been a problem. Small planets are easier to explain. Giant planets like Jupiter are harder. But objects this massive are where the story starts breaking down. Because there are two very different ways to make something like this. A star forms when a huge cloud of gas collapses under its own gravity. A planet forms from the bottom up, inside a disk around a young star, where rock and ice clump together, grow larger, and eventually pull in gas. Those are not small differences. They are two completely different origin stories, and 29 Cygni b lives right on the border between them. It orbits a nearby star at an average distance of about 1.5 billion miles, roughly where Uranus would sit in our own solar system. That made it the perfect target for Webb, because if astronomers could figure out how this object formed, they would get something bigger than the story of one strange world. They would get a better answer to where planets end and stars begin. So, Webb looked at its atmosphere, not just to see what gases were there, but to look for heavy elements like carbon and oxygen. And what it found was the key. 29 Cygni b appears enriched in heavy elements compared with its host star. That matters because stars mostly form from collapsing gas. But planets built through accretion can collect huge amounts of metal-rich solid material as they grow. In other words, this object carries the chemical fingerprints of planet formation, and not just barely. NASA says the amount of heavy elements inside it is equivalent to around 150 Earths. That is a ridiculous amount of solid material, and it is exactly the kind of evidence you would want if you were trying to prove that something this massive still formed like a planet. Webb was not the only clue. Researchers also found that the planet's orbit is aligned with the spin of its star, another sign that it likely formed within a protoplanetary disk, not in some chaotic star-like collapse. So put all of that together, and the picture gets much sharper. This is an object almost too big to be a planet, that still seems to have formed like one. That is why this discovery matters. It means the planet-building process may be able to push farther than many people expected. It means some of the heaviest worlds we see may not be failed stars at all. And it means that one of the most important lines in astronomy may be less about size alone and more about origin. So 29 Cygni b is not just another giant world. It is a challenge to the way we sort the universe, a planet-sized argument, a world heavy enough to look wrong, and one of the clearest signs yet that nature does not care where we thought the boundary should be.